Hi everybody, this is Mr. Folly, and welcome to podcast 5.1. We're going to find out how to find molar masses, convert mass to moles, convert mass to atoms, and convert moles to mass and atoms. So that's pretty much it. So get out your calculators and the periodic tables I told you to pick up in class. If not, print out a periodic table from the internet or have it in another window so you can look at it and see what we're doing with it. Let's run. A mole is an amount of atoms like a dozen. So basically what it is, it's a unit we're going to use over and over and over again. A mole of particles is 6.02 times 10 to the 23rd, which is huge. Okay, you need to know this number. You don't need to know that one. Okay. A mole of atoms equals its molar mass. So on the periodic table, there's a number below it. So a mole of carbon weighs 12.01. A mole of oxygen weighs, now we're always going to call this 16.00, okay? Because we were rounded to 2 decimal places, okay? Don't change sides. So CO2's mass is carbon, I have 1 times 12.01. And oxygen, I have 2 times 16. 12.01 plus 32 is 44.01, and my units will be grams per mole. So see how CO2's mass is going to be that, and that's how you do it. Alrighty, nice and easy. Even though 1 mole is 6.02 times 10 to the 23rd particles for anything, the masses are different. So do 2 cars weigh the same as 2 phase donuts? No, it's like this car, a little chubbier, weighs a little more. Does 1 mole of cars weigh the same as 1 mole of donuts? Now remember, 1 mole of cars would mean 6.02 E23 cars. And 1 mole would be 6.02 E23. Kind of like a dozen is always 12 donuts. So those wouldn't be the same. So does 1 mole of hydrogen weigh the same as 1 mole of iron? No. Just like 1 dozen hydrogens wouldn't weigh the same as 1 dozen irons. Hope that makes sense. The mass of Theo and Fe2O3 are different, right? And that's kind of like the CO2 I did before. Theo has 1 iron. Hey, look at iron. Iron weighs 58.85. And 1 oxygen. Oh, look, oxygen weighs 16. And we're good. Get back here. So when I add those together, 55.85 plus 16 is 71.85. And remember, again, the unit's going to be grams per mole. And the abbreviation for MOLE is MOL. What a great abbreviation. Fe2O3, this 2, means I multiply this, which is iron, times 2. This 3 means I multiply times 3 oxygen, and this is oxygen. So 2 times 55.85 plus quantity 3 times 16 is 159.70. Again, grams. That's how many grams it is. Per means divided by moles. That's how many grams it is for 1 mole. Find the molar masses. Oh, that's right. I want to get rid of one. So I go to the periodic table. Molar masses mean go to the periodic table. So remember how my units are grams per mole? I say little g stands for grams, and little g means go to the periodic table. So Na is 22.99 plus chlorine is 35.45 plus 3 times 16. And that'll be my mass. So 22.99 plus 35.45 plus quantity 3 times 16 quantity 106.44 grams per mole. Now this one's tricky. Mg is 1 times 24.31. That's the go to the periodic table. Go to the periodic table to get that number. Oxygen. Now to see that 2, get back here. This 2 means everything in the parentheses is 2. So I have 2 oxygens times 16. That's 32.00. And then get back here. And then I have 2 hydrogens. So H equals 2 times 1.01, 2.02. Then add them all up, and I get 24.31 plus 32 plus 2.02, and I have 58.33 grams per mole of MgOH taken twice. See how that 2 distributes to each? Good. Converting to atoms and grams and moles. We'll use the factor label method, so that's the times dividing bar. We did this a bunch before. You need to know the top number is equal to the bottom number. 1 mole of carbon is equal to this. 1 mole of atoms is equal to this. And when you do this, remember the first thing you want to do is given unit times dividing bar, and then that given unit is going to be on the bottom again. The number won't be the same, but the unit will always be there. Okay? And whenever we do this, one of the sides will have a mole. So mole will either be on top or mole will either be on the bottom. And you will always have 1 mole. Remember I said grams is go to the periodic table? And atoms is 6.02 times 10 to the 23rd. Moles is always 1. Problems, mass and moles. Convert 10 grams of CO2 into moles. 10 grams of CO2. I'm converting, so times dividing bar. I hate you, grams. To cancel it, I'm going to put grams of CO2 on the bottom. And I'm going to go through moles. 1 mole of CO2. Little g stands for grams, and little g stands for go to the periodic table. Carbon is 12.01, and oxygen is 32.00. Remember, I had to multiply it times 2. So I got 44.01. And then I want moles. Moles are my unit on top now. I'm golden. 10 divided by 44.01 is 0.227 moles CO2. Just to go all mathy on you, look, it cancels. That's how I killed it. 2.55 moles of water. Get back here. Water into grams. 1 mole water. All right, canceling water. Grams of water. I don't know what number goes there. Let's see here. Little g stands for grams, and little g stands for go to the periodic table. So 2 hydrogens. Hydrogen are 1.01 times 2, and oxygen is 16.00 times 1. So that's going to be 18. Get back here. 18.02. So 2.55 times 18.02 is 45.95 grams of water. Convert 6.22 grams of NH3 into moles. So I hate you grams of NH3, so I'll put it on the bottom. And I'm going to go into moles and put 1 mole NH3 on top. Little g stands for go to the periodic table. When I add all that up, I get 17.04. And then 6.22 times 17.04 is 105.05.99 grams. Okay. So nice, simple. You got moles, you got grams, it'll flip-floppy. Okay. How many particles of water are in 15 grams of water? Now notice I don't have moles in this, but I have to go through moles. Go through, that's going through, moles. So I'm given 15 grams of water. And I know I got to go through moles, but I know I got to kill water. And I want to go into moles of water. 1 mole of water equals go to the periodic table. Now I'm in moles, but I want particles. Okay, so I want to get rid of moles of water, and I want to go into particles of water. Now, and remember, there's 6.02 E23 particles in a mole. Now there are 3 types of particles. A particle can be an atom, a particle can be a molecule, and an atom can be a formula unit. So if you see any of those, you are welcome in this class to just call it a particle, and that's okay. So let's put this in our calculator. 15 divided by 18.02 times, how do I do that in my calculator? 6.02 E hit the second button, hit the comma button, which is right above the 7, 23. And we've done that before. 5.01 E23 particles of H2O. How many atoms of sulfur are there in 8.78 grams of sulfur? 8.78 grams of sulfur makes me hating grams of sulfur. Little g stands for grams, and little g stands for go to the periodic table. That's 32.07 on my periodic table. Now I'm in moles, but I want atoms. So I hate you, moles. 1 mole of sulfur. And I want to go into atoms, and I know there's 6.02 E23 atoms of sulfur in 1 mole. Atoms of sulfur are what I want. That's on top now. So let's do it. 8.78 divided by 32.07 times 6.02 second comma. The E shows up on my screen. 23. Now, if you happen to be lucky enough to have a Casio calculator, it's even simpler. You hit the X button. But if you have a Casio calculator, you probably knew that already. That's how I get atoms of S. Okay. I want to find the grams of Ni and 2.85 E23 atoms. So 2.85 E23 atoms of Ni. The notes that say Ni. And I want to go into grams, but first I have to get out of atoms. I hate you, atoms. I will cancel you. Oh, the number that goes with atoms, 6.02 E23. Because this many atoms of neon equals 1 mole of neon. Remember, top and bottom have to equal. Now I'm in moles, but I want grams. So I hate you, moles of neon. Cancel it, right? I go into grams of neon. And my periodic table says 20.18 grams of neon is 1 mole. Calculators assemble. 2.85 E23 divided by 6.02 E23 times 20.18. No E's at all. I get 9.85 grams of neon. This last one, believe it or not, is actually quicker because I'm starting with moles and particles. The one before, I had this extra step. See, I had to go through moles. See, I had to go through moles. See, I had to go through moles. The one before it, I didn't. It was just 1 step. This one was 2 steps because I had to go through moles. This one will be shorter. 2.35. Oh, you know we're almost done now. E23 formula units of Al2O3. How many moles do I have? So I have 6.02 E23 formula units and 1 mole of Al2O3. I always have to go through moles. Now, what was I trying to get into again? How many moles? Oh, wait, look. My moles are on top. As soon as the unit I want is on top, I am finito. 2.35 E23 divided by 6.02 E23. And I get 0.39 moles Al2O3. That's easy. As long as you know your moles and that number, it's quick. So now I've got 2.35 E23 molecules. I'll abbreviate that MC. NH3. How many moles? Well, I hate you, molecules. Sorry, I do. Even in this Christmas season, I'm hating molecules because I'm going to cancel it and get killed. And I have to go through moles. 1 mole of NH3. What did I have to go into again? How many moles? When my top unit is the unit that I want, I am ready to calculate. 2.35 E23 divided by 6.02 E23. There's my answer of, wait a minute, it's the same one. Why is that? Moles of NH3. It's the same answer. Why? Why? Oh, if it's the same number of formula units, it'll be the same number of moles. It's not going to be 2.35, but I did the same thing. I divided by 6.02 times 10 to the 24. That would be like if I had 36 eggs, is 3 dozen. 36 bottle rockets is 3 dozen. 36 students is 3 dozen. So So that's how you can see that moles are like a dozen. If I have 2.50 moles of S, how many atoms do I have? So I hate 2 moles of S, even in this fine Christmas season. And I'm going to go into 6.02 E23 atoms of S. And since I want atoms, I'm done. 2.50 times 6.02 E23, and I get quit, ergo 2. Darn it, why does that happen? Uh-oh, I put 2 decimal places in there. And I get 1.51 E24 atoms of S. Yeah, you know it's a review slide. G means go to the periodic table and add. 6.02 E23 particles in a mole. Remember, we've got 3 types of particles: atoms, formula units, and molecules. Oh, I guess that's right there, isn't it? And always go through moles, always go through moles, always go through moles. Toodles.